CQC, Chapter 3. Kinematics of Spatial Flows and Galactic Dynamics. Here we will mathematically explain how galaxies can rotate in that particular manner without the need to add artificial cold dark matter, but simply by using the concept of the cosmic treadmill. 3.1. The mechanism of the cosmic treadmill in galaxies, the metric flow of space. Galactic dynamics is not governed solely by classical gravitational interaction between static masses embedded in space, but is affected by the kinetic flow of space itself, generated by the central supermassive black hole, which acts as an active phase converter. The central black hole continuously consumes galactic matter and converts it into space strings, which are then ejected radially. This process sets up a metric flow of space directed toward the galactic periphery, opposing the gravitational infalling of matter toward the center. This dual movement is formalized as VC. This cosmic treadmill mechanism radically alters galactic kinematics. Space flows outward, increasing the apparent geometric distance between the galaxy's spiral arms. Stellar matter and gases, gravitationally attracted, attempt to fall toward the center, moving upstream against the flow of the outgoing space strings. At dynamic equilibrium, the rotational velocity of stars in the galactic periphery stabilizes onto a flat plateau, eliminating the need to hypothesize massive halos of cold dark matter to explain anomalous galactic rotation curves. Imagine a river. If you swim downstream, your speed relative to the riverbank will be the sum of your swimming speed plus that of the river. If you swim upstream, the two speeds will be subtracted. In CQC, this central black hole converts matter into space strings and ejects them. Space literally is born in the center and flows outward like a spherical current. In physics, to describe the flow of an incompressible fluid, or the conservation of mass, the continuity equation is used. V is c times c dot times vc, where $vec$ is the velocity field of the flow. $sigma$ represents the source of the flow. If we consider spherical symmetry around the galactic black hole of mass $, the velocity at which space expands radially outward decreases away from the center according to the inverse square law of area. V where $$ is the distance from the center of the galaxy. $x$ is the geometric flow rate of the black hole, that is the quantity of space strings generated per second. 3.2 Elastic limit of strings and the speed of light $, the composition of velocities and galactic rotation curves. In this space fabric model, the speed of light $, is not an abstract property of the vacuum, but represents the limiting propagation speed of transverse excitations along space strings. Expressing the lattice of space strings as a continuous elastic medium, the speed is calculated analogously to the speed of elastic waves in a solid or a stretched string, where $math_cal$ represents the intrinsic mechanical tension of the space strings on the brane. $O_STALA represents the quantum linear mass density of the space strings. Consequently, the photon is formalized as a pure torsional oscillation propagating along this elastic lattice. The deflection of a light ray near a massive body is not due to the curvature of an incorporeal vacuum, but to local elastic deformation and crowding of space strings caused by the tension induced by the body's mass. In real galaxies, stars and gas rotate around the center. According to classical Newtonian physics, the orbital rotation speed $, of a star at distance $, should decrease as distance from the center increases. V, however, astronomical observations show that at large distances, the speed of stars remains constant, creating a mystery that mainstream physics attempts to resolve by adding tons of invisible dark matter around the galaxy. In CQC, the solution is kinematic. The star moves on a spatial grid that is itself moving. The total velocity we measure from Earth is the result of the vector addition between the star's orbital movement on the grid and the expansion movement of the grid itself, Vec. Because space flows outward, pushing the star radially, and gravity pulls the star inward, a dynamic coupling is created. When we calculate the effective acceleration experienced by the star, we must account for the drag term of the space flow. Without entering into terrifying tensor calculations, this coupling introduces a correction to classical gravitational acceleration. A in galactic peripheries. The term linked to the flow of space $a takes over, preventing the star's velocity from collapsing to zero and keeping it stable at a plateau value. We have explained the rotation of galaxies using only geometry and fluid mechanics applied to the space fabric. The speed of light is mechanical stiffness. In the 19th century, physicists knew that the speed of a wave in an elastic medium depends on the physical properties of the medium. Specifically, it depends on stiffness and density of the medium. V. If space is a lattice of space strings, light is not a particle flying through nothingness, but a transverse oscillation propagating by hopping from one string to another. The speed of light $, is therefore the propagation speed of this mechanical vibration within the modern ether. See where $mathcal$ is the intrinsic mechanical tension with which space strings are stretched on our cosmic brain. $_$ is the quantum linear mass density of these strings. What does this mean for physics? It means that the speed of light is not a magical constant handed down from above, but an elastic property of space. If, in a certain region of the universe, the tension of the strings varies or the density of the lattice changes, the local speed of light will also undergo a microscopic variation. This provides a purely mechanical explanation for the bending of light rays in redshift.